Next, they are miscellaneous type, which is not of any standard form. So far discussed, but they give miscellaneous forms. So these are not in one of the standard forms. All right, but we need to solve them using just the logical concepts. So first one, limit x tends to 0 plus modulus of x to the power sin x plus sin x to the power x. This is the limit. So look at this. Which form is this in? Which form is this in? Now this is some indeterminate form plus an indeterminate form. We can easily split this into two limits. Now tell me which form is this in? Each of these. Okay, I'll call this limit as m and this limit as n. Now these are as x tends to 0 plus, modulus of x will become x. So mod need not be written. So this is x power sin x. X tends to 0, sin x also tends to 0. So this is 0 raised to the power 0. Same here, it is 0 raised to the power 0. Both of these are 0 power 0 form. Now we do not know what is the value. So let us look at this one, m. M is limit x tends to 0 plus. I will write this as x power sin x, the first one. So to find this out, what we'll do, take log on both sides. This is log, natural log. When I'm just writing log, it is a natural log. So I get log x to the power sin x, which is nothing but sin x into log x. Now this part becomes 0, and what does log x become as x tends to 0 plus? As x tends to 0 plus, what will be the value of log x? Answer? Anyone?
Minus infinity.
Minus infinity. Very good. So remember the graph of log x. Now as x tends to infinity, log x will go to infinity. But as x tends to 0, log x values go to minus infinity. So this is 0 into minus infinity. So what we can do is, I will write like this, limit x tends to 0 plus, I will write this as log x by cosecant x. Now this becomes minus infinity by infinity form. So to solve this, I will use the L'Hospital's rule. When I use the L'Hospital's rule, I get limit x tends to 0 plus log x, derivative is 1 by x, and cosecant x is sorry, minus cosecant x cot x is the derivative. Is the derivative of cosecant x. So it is sine. So let us write that differently now. Limit x tends to 0 plus cosecant comes to the numerator, becomes sine. So I get sine x upon x with a minus sign, and cot x becomes reciprocal of cot x is tan x. So, okay, writing it here. When you apply the limit, sine x upon x as x tends to 0 is 1, and tan x as x tends to 0 will tend to 0. So it is 1 into minus 1 into 0, it is 0. So this limit log m to the base e is 0, which implies m is e power 0, which is 1. So this limit tends to 1. Very interesting. This is an important limit. This tends to 1. This is how we need to do. Second, what is the second part? Sorry, yeah. The second part, n part, limit x tends to 0 plus sine x power x. So m is 1. Now n. So this is equal to n. Now take log of n. So log of n is limit x tends to 0 plus x log of sine x. Again, this is 0 into minus infinity form. So I'll convert this like this. I'll retain log sine x, and this x I'll bring to the denominator. Now this becomes minus infinity by infinity form. So to solve this, I will use L'Hospital's rule. Now we get limit x tends to 0 plus derivative of log of sine x is 1 by sine x into derivative of sine x is cos x. And here we get minus 1 upon x square as the derivative in the denominator. So we get limit x tends to 0 plus. Now I take this x up. So x upon sine x with a minus sign into x into cos x. Now limit as x tends to 0, sine x upon x is 1. So x upon sine x will also be 1. But x will tend to 0, and cos x as x tends to 0 will be tending to 1. So again, this limit, because of this x, it tends to 0. So log of n to the base e is 0. So n is e power 0, which is equal to 1. So m is equal to 1 and n is equal to 1. Therefore, the given limit m plus n, 1 plus 1 is equal to 2. So this is the given limit. This is an important, very important problem type. Okay. Limit n tends to infinity. 4 power n plus 5 power n whole to the power 1 by n. Answer. See, this is infinity power 0 form. Now there is no standard result for this. And you cannot take log also both sides, because this has to go to 0 if you have to take log. If you take log both sides, it will go to 1 by infinity, 0 into log of an infinite number. That will not give us anything. Common sense logic is, we know that if a number is less than 1 and x tends to, or a number lies between 0 and 1 more strictly, and as n tends to infinity, this will go to 0. X power n will go to 0. This concept, this logic we have to use here. For that, what we'll do, we'll take 5 power n outside. So limit n tends to infinity, I will take 5 power n outside of the bracket. So I get 4 upon 5 whole power n plus 1. This whole power 1 upon n. Now this 5 power n into 1 upon n is 5. Okay. Now this, okay, I'll write limit within the limit only. Limit n tends to infinity. 5 power n whole power 1 by n is 5. And we are left with 1 plus 4 by 5 to the power n. Raised to the power n. Now, this is a number which is tending to 1. And power is tending to 0. Now, anything that tends to 0 will go to 1. Anything tending to 0 will be equal to 1. And this is a number which is small, 1.0000 raised to the power very close to 0. Okay, so this will tend to 1. So we have 5 into 1, which is equal to 5. This is the answer. This is the answer. Limit x tends to 0, e power 1 by x minus 1 by e power 1 by x plus 1. This does not exist. This is the answer. How? See, whenever x tends to 0 and we have 1 by x, we need to be very, very careful. Consider the left-hand limit as x tends to 0 minus. What happens? 1 by x will tend to what? It will go to minus infinity. Because this is a small negative number. It is approaching 0, but from values slightly less than 0. That is, it's a negative number. So 1 upon x will go to minus infinity. Okay. So in that case, this will imply e power 1 by x. This will tend to 0. Okay. So left hand limit will be limit x tends to 0 minus e power 1 by x minus 1 by e power 1 by x plus 1, which is 0 minus 1 by 0 plus 1, which is minus 1. Is this clear? Is this clear? For this, you need to know e power x graph thoroughly. So look at this e power x graph. Yeah. Now e power x graph, as x tends to infinity, e power x goes to infinity. Okay. And as x tends to minus infinity, e power x is approaching 0 only. E power x is approaching 0. Okay. So just look at this now. So that's what, when x tends to 0 minus, 1 by x is tending to minus infinity. So e power, a term which is going to minus infinity, will go to 0. So that is, as whereas right hand limit, as x tends to 0 plus, 1 by x will go to plus infinity, which implies e power 1 by x will go to infinity. So if this goes to infinity, then what we need to do? It is infinity by infinity form. So limit, right hand limit is limit x tends to 0 plus e power 1 by x minus 1 by e power 1 by x plus 1. This is going to infinity upon infinity. So limit x tends to 0 plus, we will divide by the infinity term. 1 minus, I am dividing by e power 1 by x. I am dividing by e power 1 by x. So 1 minus 1 by e power 1 by x upon 1 plus 1 by e power 1 by x. So e power 1 by x is tending to infinity. So its reciprocal will tend to 0. So I'll get 1 minus 0 upon 1 plus 0, which is 1. So left hand limit is minus 1 and right hand limit is plus 1. So left hand limit is not equal to right hand limit. Therefore, limit does not exist. Now we can use Maclaurin series expansion in other cases. For example, this is one example. I'll give another example of using Maclaurin series, which is the problem we have done yesterday. Limit x tends to 0 plus, x tends to 0, tan x minus sin x by x cube. The answer we got for this is half. We used L'Hospital's rule, and I used the basic method. I wrote sin x by cos x, and I took sin x common, and then 1 minus cos x we wrote as 2 sin square x by 2, and then we solve this. Now let us use Maclaurin series expansion for this. Now, so sin x is x minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial and so on. We don't have to go that far. Bottom is 3, up to 3 we have to see. Tan x is x plus x cube by 3 factor, x cube by 3 plus 2x power 5 by 15. Sufficient. We don't have to go further than that. However, we have the series here, so I'm doing it. So tan x minus sin x, tan x minus sin x becomes, so subtract the first series by the second. So x minus x 0, then x cube by 3. This is x cube by 3 minus x cube by 3 factorial. 3 factorial is 6 plus x power 5 2 x power 5 by 15 minus 1 by 5 factorial is 120. Then x power 7 term, you don't have to do anything about it. You just leave it like this. It goes on. The first term is important for us. So this is 2 minus 1. So I get x cube upon 6 plus this also we can do 15 into 8, 120. So this is 2 into 8, 16 minus 1. So we get 15 by 120, that is 1 by 8. So sorry, the first term is x cube by 6. This is x power 5 by 8. Then this is x power 7 into some number and so on. And next term will be x power 9 and so on. Now we have limit x tends to 0, tan x minus sin x by x cube. So write this expression. Just a second. Oh, I'm sorry. This is minus and this becomes plus. I did a mistake here. This is plus. This is also plus. So this is x cube by 3 plus x cube by 6. That becomes 3 by 6. This becomes 1 upon 2. I'm sorry. And this term remains as it is. So we have, you divide this expression here by x cube by 3. Sorry, by x cube. Then we get 1 upon 2 plus x square by 8 plus x power 4 into some value plus next is x power 9 by x power 6 into some value, something like that. Now as x tends to 0, all the terms other than half go to 0. So we are left with 1 by 2. That is what the answer we got.